All right, hi again. So today we're going to talk about special angles, more specifically with exact values of a trig ratios of those special angles. And whenever we talk about exact values, that means no calculators involved. So you can't take out your scientific calculator and take the trig ratios of whatever that number is to get the angle. So for the purpose of this, we're going to start with two triangles. The first triangle that you can see is a right angle triangle. It is a 90 degrees right here. We have a 90-degree sine, so it's a right angle triangle. And the special part of this triangle is that the two sides or the legs of this right angle triangle, they're equal length. That means that, and for simplicity's sake, we're going to measure them at 1 unit each. So 1 unit each. And using Pythagorean, we know that a hypotenuse AC is √2. Excellent. The other thing about it is that we know what these angles are. That's 45 degrees. That's 45 degrees. The angle A and angle, so angle A, which is equal to angle C, that's one of the reasons, that one of the criteria for being isosceles. They're 45 degrees, in this case 45, because the sum of the interior angles of a triangle must add up to 180 degrees, so each one of them should be 45 degrees. Great. If we are going to use radians measure, 45 degrees is pi over 4. Remember, pi was 180 degrees, right, in radians measure, and divided by 4, that's 45 degrees. So you have the radians measure, you have the degrees measure. In grade 10, we don't deal with radians, we only deal with angles, but in grade 11 and 12, we will deal with radians measure. All right, so now let's go ahead and write all the trig ratios for the 45 degrees. And we know what they are. So let's go ahead and do that. Sine of 45 degrees is opposite over hypotenuse. Remember, opposite hypotenuse. And then we're going to continue doing those and then come back and then finishing them all off. Okay, for sine and cosine we have right here, and then tangent we also have right there. We wrote all the original definitions. Opposite over hypotenuse, that's the length of the opposite side to that angle. And when we are dealing with sine of 45 degrees, because both of these are the same, angle A and angle C are both 45 degrees, so it doesn't matter which one we choose. Let's suppose we're choosing this angle right here. Okay, just for simplicity's sakes. So that's the 45 degree angle that we are choosing. All right, by the way, both will give you the same values anyways. All right, let's go ahead and write up the ratios. Opposite of 45 degrees, so that's opposite 1. If you notice that, that's 1 right here, and then over √2. So this, the first one would be 1 over √2. Okay, cos of 45 degrees, adjacent. So the adjacent side now is this one. That's the adjacent side beside that, right? So adjacent over hypotenuse, so this would be 1 over √2. Okay, 1 over √2. And then the last one will be the regular opposite over adjacent, and opposite of 45 degrees, that would be again 1. And then adjacent would be 1, so it would be 1 over 1, and simplifying it will be 1. So here it is. Sine of 45 degrees is 1 over √2. By the way, if you rationalize the denominator, and you don't know what that is, and if you're in grade 10, but in grade 11, you do know what that is, that's √2 over 2. Same thing. Some books they have it as 1 over √2. There are some books they have it as √2 over 2. They're both the same. So sine of 45 degrees in exact value is √2 over 2. And so as cos of 45 degrees are both the same, and tangent of 45 degrees is 1. That's the exact value. You're not using a calculator. All right. So that is the way to come up with the exact ratio, but using a special triangle. This triangle is a very famous triangle. It's called the 1, 1, √2 triangle. Okay, and I use a symbol triangle because I'm very lazy. Okay, so if you want to remember that, if 1 root 2 is that root 2 is the hypotenuse and 1 and 1 is the both sides. So this is where the angles are dealing with, is 45 degrees. Excellent. Now we're going to go to the next one. Okay, the new triangle is a special triangle with the special angles, and this is the 30, 60, 90 triangle, or 1 root 3 2 triangle. The way we set this up is like this. We have this triangle, right angle triangle, and if the length of the hypotenuse, so this is the hypotenuse right here, if that length is twice the size of the smallest length, which is this one right here, 1, then we'll have this special triangle where the angles will be 60 and 30 degrees. Okay, so the inside, so once we have the 60-30 triangle, we can come up with the other missing side. So it's the length of CB. When you do the Pythagorean, it will end up being root 3, because 2 squared is 4, 4 minus 1 squared is 3, and then the square root of that will be root 3. So this triangle is very famous, and it's called 1 root 3 2 triangle. And now we're going to go ahead and write the ratios for the 30 degrees and the 60 degrees without using a calculator. So let's go ahead and do that. All right, sine of 30 degrees, we have the 30 degrees which is right here. Let's deal with the 30 degrees first. Okay, so now opposite is, that's the opposite to the 30 degrees, so 1, and hypotenuse is 2, so it would be 1 over 2. Remember, hypotenuse, opposite over hypotenuse, that's the sine. Cosine is adjacent, and adjacent is right beside it, so that's root 3 over 2, root 3 over 2. Okay, adjacent over hypotenuse. And tangent of 30 degrees is opposite over adjacent, and opposite is 1, and adjacent is root 3. And you rationalize the denominator, becomes root 3 over 3. Some books have it written like that. All right, let's go ahead and do the sine of 60, cos of 60, tan of 60. Same idea. We're going to start with the second one on top. So that's the 60 degrees now. Okay, so that's what we're doing, 60 degrees, 60 degrees. All right, so opposite of 60 degrees is root 3 and 2. So here it is. Sine of 60 is root 3 over 2. Cos of 60 degrees, adjacent to it, now remember, adjacent is the adjacent to the angle, so that's 1, that would be 1 over 2. Okay, and then the next one, tan of 60, opposite over adjacent, and that would be root 3 over 1, which is equal to root 3. These are the exact ratios for these special angles, the 60 degrees and 30 degrees. By the way, 60 degrees in radians is pi over 3, which is 180 degrees divided by 3 is 60, and 30 degrees in terms of radians is pi over 6. All right, now when the question says use exact values to answer the following questions, that's what you need to do. You cannot use a calculator, and you have to come up with the exact ratios. So when I say sine of 60 degrees, that is equal to root 3 over 2. Simple as that. Don't take out your calculator and give me some decimal expansion number. That's not the exact value. All right, that's the end of this lesson. More practice and you'll get better.